Hi everyone, I'm Hassan and I'm here to introduce you to an efficient evolutionary wrapper-based feature selection strategy for both low and high dimensional problems. This method also is novel and fast with name SIFE, set-based integer-coded fuzzy granular evolutionary. S set-based, I integer-coded, F fuzzy, and E is evolutionary. We have two parts of sife. This is the first part that follows the concepts of sife. We have the second part that follows Matlab code of sife. How to use sife in Matlab. Please see part 2 of sife. Here is the original paper with title Set-Based Integer-Coded Fuzzy Granular Evolutionary Algorithms for High-Dimensional Feature Selection. That was published in the Applied Soft Computing journals in April 2023. I recommend reading the article for more detail. Here we have the introduction about feature selection. Feature selection plays a leading role in handling high-dimensional databases by keeping only the most valuable or useful or relevant feature subsets. It has three main benefits, such as leading to less computation, improving performance, accuracy for the classification problem, RMSE for the regression problems, and higher transparency in decision-making process. The main contributions of sife. We have three contributions: integer coding, set operation, and FG fuzzy granulation. 1, 2, 3. We propose the integer coding and fuzzy granulation as an integral part of the evolutionary wrapper-based feature selection method. 2. Based on this integer coding, we redesigned crossover and mutation operations that employs set operations such as union, intersection, and complement, aiming to a better search in the evolutionary process. 3. Fuzzy granulation. In addition to its common use as a surrogate techniques to avoid unnecessary computation by recognizing similarities, the fuzzy granulation concept also operates as the repulsive strategy that searches for dissimilarities in the elitism and population initialization to reach higher population diversity. In summary, fuzzy granulation has two roles in sife. First, reducing the computational cost, for example, CPU runtime, and promoting the diversity in the evolutionary process. What is the integer coding and what is the difference between binary and integer coding? Binary coding is the most well-known scheme for the feature selection. For example, consider a dataset with 10 features. We have two candidate solutions, S1 and S2, in the form of a binary coding feature selection. 0 means the first feature is removed and 1 tells the second or third feature is selected. And here the indexes of each feature 1 to 10. Here are the indexes of the first to 10 features. Despite a binary coding, in integer coding we use indexes instead of binary codes. We use indexes of the corresponding feature. For example, 2 is if selected features. The second feature is selected. 2, 1, here indexes of third feature. 3. We use directly indexes of feature instead of 0 or 1 as a binary coding. 2, 3, 5, 8, and 10. Convert S1 in binary form to integer form. S2, 1, the index 1. 3, 5, and 7. The set of indexes of selected features. We use directly of indexes of selected features. Using the integer coding, we propose two variation operations. For example, crossover and mutation. Here we have the three parent crossover. Compared to the conventional crossover, we involve three parents instead of two parents. Two of them here, selected by roulette wheel mechanism. And the third one is selected randomly, is chosen randomly. The two offspring are produced, the two offspring O1, O2, O1, O1 and O2 are produced by combining a union and intersection set operations. The intersection of S1 and S2 creates the O1, and the union of O1, J1 and J2 produces the O2. It's very simple. You can have two offspring or two new solutions by following only these four steps. And this figure is an example of the producing two offspring O1 and O2 with set-based three-parent crossover. The second variation operation is complement mutation based on a set theoretic operations concepts. This also is very easy. Here we only need to calculate the complement of full features and current solution, candidate solution, as a current chromosome in the concepts of genetic algorithm. Then we randomly select n genes. For example, here we replace two genes from Si as a current solution and its complement. We replace two genes. Here is an example. Replace two genes from its complement. 6, select 6 and 1 selected from its complement, and replace these genes with 3 and 10. 6 and 1 replaced. This is very easy. You can follow these descriptions. And the third contributions as a fuzzy granulation. The story of fuzzy granulation is long. You can read the paper for more details. In summary, it has two leading roles in sife. The first rule is reducing computational by detecting similar solution and avoiding unnecessary computations. The second role is to promote population diversity by passing the generation in two steps of sife in initialization and elitism elements of GA, genetic algorithm. And this is the flowchart of the proposed algorithm for feature selection. In the data analysis part, the initial data is filtered with two well-known pre-processing methods such as filling the missing values and normalization. Then the data is randomly divided into the train and test data. And the training data is processed with k-fold, and sife is here with its elements. For the initialization step here, we have the fuzzy granulation based population initialization to create a high diversity initial population as a P. And then the main loop of sife is started. For example, to 100 iteration or 100 generations. Here we apply the set-based variation operation to produce new solution, new offspring, new chromosome. And here is applied fuzzy granulation to reduce the computational cost and keep an archive of dissimilarity solution to promote diversity as a elitism, fuzzy granulation based elitism. And here we describe the experiments, our experiment. Note we use 22 benchmark classification problem to validate our sife. And you contact with me with these two emails, and here is the link of Matlab code of sife. You can download freely in GitHub. And it is my Telegram channel with more than 200 courses in optimization, deep learning, machine learning, and so on. And here is the references. And finally, sife in Matlab. Please see part 2 for using sife in Matlab and read the description of the video. Thanks.